Hi everyone, today I will test surface mount varistors for presence of silver. This is not a tutorial, do not repeat anything shown in this video. I got my hands on a sample of surface mount varistors. Some are finished, some are not. But it doesn't matter because they're both more than good enough for what I will be doing with them today. Varistor is a surge protecting electronic component. Most of the time, a piece of mixed metal oxide ceramic with a resistance that changes with applied voltage. What interests us today is the thin layer of metal that is applied to its contact surfaces. Such contacts often contain silver because of its incredible electric conductivity and corrosion resistance. I started by making a mixed sample from finished and half-finished components. To extract silver, I first burn the components to remove the plastic and allow the acid to reach the metal-plated ceramic discs inside. With plastic removed, now you can see the contacts. I then transferred the varistor ash into a beaker and leached it with dilute nitric acid. The solution slowly turned a striking blue color. Giving the acid 2 days to dissolve everything that there is to dissolve, I then filtered off the solution into another clean beaker. After preparing a clear solution of all the nitrates, I added a small amount of hydrochloric acid, which should precipitate silver as silver chloride. Indeed, there was a visible white precipitate, but the small amount of it doesn't bode well for the silver content of the components I'm testing. Precipitating silver chloride in this way, when there is significant amount of silver present, produces large volume of fluffy white precipitate. The fact that all the silver chloride we have is colloidal tells me we have very little silver. Even 0.1 gram would produce much more precipitate that would settle down fast. This colloidal precipitate took an entire day to settle to the bottom of the beaker. After silver chloride settled to the bottom, I attempted to carefully decant the solution. This wasn't possible without losing much of the silver chloride, because even the slightest disturbance turned much of the silver chloride back to the suspension. I couldn't filter it either, because fine particles would pass straight to the filter paper I have. Seeing neither decanting nor filtration would do, I attempted to search for another solution. I settled for a less use approach. I add enough ammonia to dissolve silver chloride and in turn precipitate all the metals that form insoluble hydroxides and do not dissolve in excess of ammonia. Then I filtered off the clear solution that should contain silver in form of tolerance reagent. Having washed the precipitate with a lot of water, I then attempted to reduce the silver with metallic copper. There was no reaction even after polishing the pipe to expose fresh unoxidized metal. Adding reducing sugars in form of honey brought no better results. The logical conclusion was the silver was still in the precipitate, so I used more concentrated ammonia to dissolve any potential silver oxides that are stuck in the filter paper. After letting it react for a day, I once again filtered the solution that would hopefully contain silver. I have lost. I then slowly added small amounts of hydrochloric acid to reacidify the solution and precipitate any silver in it. There was no visible precipitate, but I nonetheless let the solution to stand overnight and hoped for the best. All those additional steps and complications, and all I achieved was that I lost almost all silver chloride. More than if I just simply decanted the thing and ignored the losses. Not being able to weigh actual amount of silver, I can only estimate its concentration in starting material. Based on my previous experiences with similar components, the amount of precipitate, and my tests on the varistors I had published on my channel, I would say silver content is less than 0.1%. My number may be off, but they're certainly not profitable to process. Thank you for watching, like, subscribe, and see you next week with hopefully better results.